All right, Wizards, here's a little overview of what we're going to do this week in class. Remember, it's a 4-day week. You don't have school on Friday, but we do. And then it's a 4-day weekend. So you have that to look forward to. We're going to work in chapter 6. It really is a repeat of what we did in chapter 5, but we're going to put a more of kind of a formal spin on things and really work on getting you to write a really good single response. Some of the available resources. Here's a reminder about what sampling distributions are, so you can watch that video. And there's also the Google Slides that also accompany this section in the book, or the entire chapter, so you can watch those. So there's a lot of things that you can do if you'd like to. So here's the overview of this week. And the problem I'm going to use is this working at home problem. And so according to the U.S. Census Bureau, 43% of men who worked at home were college graduates. So in a random sample of 500 women who worked at home, 162 were college graduates. So based on that sample, we want to estimate the proportion of women who are college graduates. And then a little bit later, we'll see if perhaps that proportion of women is different from the 43% of men. So just a couple of reminders. A confidence interval has two parts: a point estimate, which is our p-hat, and the stuff that comes after the plus and minus, which is the margin of error. And then remember, the margin of error has two parts. There's a critical value, which is the z star, that special z-score that creates the 98% or the 95% confidence. In this case, it's 98% confidence. And then there's the standard error of p-hat, which is the p times q over n. So remember those things when you're writing your confidence intervals. And so this was on the board a couple weeks ago, but the AP way for writing confidence intervals, we've got a mnemonic device which will help you remember the 5 things you need to include, and that mnemonic device is panic. Panic. And each of those letters in the word panic stands for something, kind of gives you a reminder of what you need to include in your solution. So the P, for example, is what parameter are you being asked to estimate, and with what level of confidence? So in this question up at the top, I want to estimate the population proportion of women college graduates who work at home with 98% confidence. Another way to look at the P is that you're restating the problem. But again, it's how the AP folks will grade your response, and therefore how I will grade your response. The A in panic stands for assumptions and conditions in context. So we've been checking these conditions for a while now. This is not a surprise, but we need to work on our context. So the 500 women who worked at home were selected at random. It says so in the problem. And just remember that random selection helps to ensure that the observations are independent. In the sample, 162 women who worked at home were college graduates and 338 women who worked at home were not. Both of those are greater than 10, which I did not type in there. And that's what we want. We want the successes and failures to be greater than 10. We've been calling this the big enough condition, but it's officially called the success-failure condition. And then the last condition, your book doesn't necessarily check this. In the AP, sometimes they do, sometimes they don't. But we can assume that the 500 women who worked at home that they sampled are less than 10% of all women who worked at home. So those are our assumptions and conditions. So the next letter in panic was N. And N stands for name your interval and write your normal model. So the name of this interval is a 1 proportion Z interval. So I would say the conditions have been met, so I can construct a 1 proportion Z interval. Probably the only thing that's missing there in that statement is with 98% confidence. And then the normal model I'm using, is we've been doing this for a while now. My normal model has a mean of 0.324 and a standard error of 0.021. So P stands for identify your parameter. A stands for your assumptions and conditions. N stands for name your interval and your normal model. The I stands for construct your interval, interpret your interval. So we've been building confidence intervals for a long time now. and we've been interpreting. I am 98% confident that the true population proportion of women who are college graduates who work at home is between 0.275 and 0.373. And you did really well on that on your quiz last week, so that's not a big deal. I think you guys are going to be just fine this week with this. The C stands for context. So if I added a little bit more to this question, for example, based on the confidence interval, is it reasonable to believe that the proportion of college graduates among women who work at home is the same as the proportion of college graduates among men who work at home? So, is it reasonable to conclude that 43% of women who work at home are college graduates? Well, the 43% for the men is entirely above the 98% confidence interval for the proportion of women who worked at home. So I can conclude that the proportion of college graduates among women who work at home is less than the proportion of college graduates among men who work at home. So sometimes your conclusion will end at the I step, saying I am 98% confident. Sometimes your conclusion will stop, that will be your conclusion. Other times there'll be another question you'll need to answer, and you'll need to make sure that is in context. The last thing we're going to do this week is a problem like this. So the margin of error for the confidence interval is 0.049. That's the special z-score, 2.323 times the standard deviation or standard error. So the margin of error is 0.049 or 4.9%. How large a sample would I need to take so that the margin of error is 3% or less, using the same confidence level? So to do that, we need to solve this equation that is here, that equation. But you really don't need to solve that equation because your calculator will solve the equation for you. All of our calculators have something called an nsolve command, and I'll show you where that is this week on your calculator, but if your calculator's at home, you could probably find it. It is an algebra thing. And so when I do the nsolve, it solves that equation for me. And the answer is 1,316.64. The only thing we need to do is we just need to round our answer up to the next integer. So in order to get our margin of error down to 3% or less, we would need a sample size of at least 1,317 women. There's some small modifications that we'll learn throughout the course of this week to this formula here that will give us a more conservative estimate, but for right now, those are the things we're going to work on this week. The panic mnemonic device, which will help you to remember the steps for your confidence interval problems, and then finding the size of our sample that we will need to get a certain desired margin of error. So that's what we're doing this week, kids. Hope this is helpful, and I will see you on Monday.